Okay, this is ionic bonding review, very brief. We do a lot of ionic bonding when we do nomenclature and the periodic table. You're simply transferring an electron. When groups 1, 2, or 13 bonds with 15, 16, and 17, you get a lot of ionic character. It has to do with electronegativity. Electronegativity. Okay, let's write that down. Electronegativity. The highest electronegative element is fluorine, just above chlorine, 4.0. The lowest here is francium or cesium, that area, bottom left, and that's about 0.6, 0.7. So if I get an ionic character, let's say the difference is 3.4, 3.3, 3, 2.5, that's going to be very ionic. And the nature of ionic bonding is there's a full transfer of the electron. So for instance, here's the electron configuration for sodium, and here's the electron configuration for chlorine. Here you have the 3s1 electron for sodium, and here you have the 3p5 electron for chlorine. What happens is this transfers down to here, so we'll make that transfer, and then you get rid of this, and then you get this. That becomes a 6. That becomes a 6. Okay? And then this that's the -1 charge, that's the chloride ion, and this becomes +1 charge. And that has a valence shell similar to neon. So that's how the metals will satisfy the octet by giving up electrons. So you can see right here, here's the octet, that's neon, and then here's the octet for chlorine, argon. And each particle, there's that word particle again, each particle is called a formula unit, not a molecule. A molecule is a particle where you have covalent bonding, and we'll talk about that in the next film, short film. Okay, so that's really it. You get the transfer of the electron, the actual transfer, you get the new valence shell of a noble gas. It has to do with differences in electronegativity. The greater the difference, the more ionic character it has. And it's very gray. Some ionic substances are very ionic. For instance, francium fluoride, very ionic. And some are not so ionic. Aluminum oxide, it's not very ionic. But we consider it ionic, depending upon the conditions under which we're using it. So that's ionic bonding. Remember, transfer, it has to do with electronegativity, and you have the satisfying the octet, and the ions are similar to the noble gases in terms of their valence shell. That's it.